Hi, everybody. Emily is correct. I am Mark Woods from Applied Pavement Technology. So this project was obviously funded through AOT research. Special thanks to our key point of contact, Reed Kinry with the Asset Management Bureau, and of course to Emily and Ashley. This is a pavement performance modeling project. A little background on it is, for all of the 3,000 plus miles of road that Vermont has, or Vermont AOT manages, they measure condition on all those roads, store it in a database, and use the data to predict condition of pavements for future years. That includes, well, I have information on the couple of indices. They use performance models to predict the condition of all those pavements. And they have had those for about 20 years, but the models they were using were established 20 years ago. There's also a couple other metrics that have been established since 2004 and new treatments. One of them, there's now some federal measures for measuring the performance of pavements. And VTrans has actually implemented some new paving treatments that they did not have models for. Some of the data included for the project, of course, the condition of pavements. The way Vermont measures pavement condition is they have an index for rutting, structural cracking, transverse cracking. IRI was just the general smoothness of pavement. And there's a new one called the National Performance Measure for Cracking, which is required by federal highways for submittal on the National Highway System. They had some additional data that's used to separate models. One of them, just the type of pavements. One they call an asphalt and concrete. You can see these other ones, thick on strong, thin on strong. They're categories of pavements that really affect the deterioration. Some deteriorate differently than others. And then you predict pavements based on the last time it was paved. So you have a performance model. The model is reset when you repave the model, obviously. So they have pavement treatments that align with that construction history, ranging from reconstruction to pavement overlays and some in-place recycling treatments. So all that data is varied segment lengths. Pavement condition is generally collected in 10th mile segments, but base types and project lengths, people don't do 10th mile paving projects. They do 5 and 6 miles. So you can see in that graphic there, the first step is really just to align everything to get uniform segments. When you put that data on a chart, plotted against time, it usually is a really, really huge, messy scatter plot because pavements are inherently variable. So the first thing you do is try to clean the data up and identify outliers, and then see the general shape of data. One of the things that made the project interesting, it was not just like a basic data regression in Excel, is because the models that are built are not always applied at the day of construction. In pavement management, for one, you're often applying a model to a segment of roadway that already has 5 or 6 years of data. So you have to fit the model to the most recent value of performance. And the performance models are used for things like you're predicting network level condition to identify funding needs and identify potential future paving projects, develop a paving list. And then there's an optimization process that calculates the area under that curve. So Vermont has special model forms that force those models onto the axes, which made the regression a lot more complicated. You have to consider that when the models are used, they're not applied directly on top of the data, they're shifted to fit. So those considerations meant that a lot of traditional regression techniques are not won't work. Because they had existing models, one of the end products of the project was that we would see the model fit for the proposed new model and compare it to the models that existed. So we found measures of error. We actually use what's called the mean squared error because it's a better measure of a nonlinear model. We use that to evaluate whether the old model was good enough or the new one was good enough. Ultimately, for all those combinations of pavement type, treatment type, and the different performance measures, it turns out to be about 140 different models. For all of the situations in which Vermont already had one, we found that the new model was a better fit using recent historical data, and also tended to show that actual performance was better than what the previous models were showing. And there were some occasions when there wasn't enough data to build a model, so we built some surrogate models. And like I said, the mean square error was reduced for all combinations that had existing models. I did not time myself. I think that was probably 4 minutes. But if anybody has any questions, I'm in the back corner over here under the far back left basketball goal. Look, feel free to come visit me and ask questions. Otherwise, thank you.